Welcome. Using this demo, we will present to you one of the possible usages of our product T-Logic monitoring for SOA, abbreviated to TMON. TMON is a central log handling tool having the main function to process the log messages arriving from individual components of processes spanning multiple systems and to display those in an easy-to-interpret way, even for business users. This way, it is possible to monitor on the TMON interface the statuses of individual process instances, where in which component they ran on error, respectively how much time they spent in the individual components. Due to its functions, TMON can be used efficiently for debugging in production or during integration testing, respectively for creating and displaying statistics for audit or other purposes. In this example, let's consider the complex SOA system of a fictive bank where the components and services send XML-based log messages to the logging service, following the hierarchy implemented when planning the logging and based on the correct logging methodology. In the demo, the developers want to check, based on received log messages, whether the process executed properly and whether the process steps call each other using the appropriate interfaces. Let's suppose that a developer or a tester is using the TMON viewer interface and would like to see, during testing or at the end of it, those transactions that were performed on the same day, October 3rd, and ran on error. The erroneous transactions can be listed using the status quick filter, selecting the failed status, and the transactions for October 3rd can be filtered using the process date quick filter, so we enter October 3rd in this field. There is a logical AND operation between the specified conditions. Activating the quick filter, the erroneous transactions for October 3rd can be viewed. Following this, let's analyze a given process, practically a test case. Let's find what caused the error. Let's check the transfer process of type money transfer. We can see that there are 3 process steps associated to it: a customer identification, a coverage checking, and an amount transfer. In case of the coverage checking, we can see 3 log messages. Let's check the process step causing the error. We can see that the amount transfer step caused it, and there are 3 log messages associated to it. From the appropriate log message, it can be determined that within the money transfer process, an amount transfer has been performed and ran on error. It was executed by a user named Robbie. The complete message contains a custom part that is the message participating in the communication. In the present case, since it is about money transferring, it contains the 2 accounts between which the transfer was made, the transferred amount, currency, etc. Based on the message content, it can be verified whether it complies with the specification, and the location of the error can be specified. In case of background systems, or for example, solutions built on the message broker product, the processing paths are pretty diverse and at the same time form a complex system. In case of an organization working with many suppliers, a significant saving in resources can be achieved through the fact that the location of the error and the responsible who must fix it can be indicated immediately. Obviously, in case of test cases, not only the erroneous cases, but the ones not showing errors can be verified as well, in order to check whether they have really touched all processing steps and components that need to participate in the given process.